In this video, we're going to go over all the options you have when configuring a PLC open axis. This includes choosing if it's a servo axis, virtual axis, or a digitizing axis connected to an external encoder. Also, this is where you set up user units for the axis and choose if you want to have rollover turned on or not, and at what position. Setting up a PLC open axis is done in the Project Explorer of the KAS IDE software. Under the PLC Open section, which is under the Motion and Controller subsections of the Project Explorer, there's a list of all the axes already created in the project. If you'd like to create a new one, you right-click the PLC Open section and choose the New Axis option. This will have a pop-up asking you to name this new axis that you're creating. You can always change this name later. Once an axis is there, you can double-click on it or right-click and choose Properties to bring up the PLC Open Axis data pop-up screen. Here you can change the name like I said you could. There's also a number of different options for this axis. First, you can change the type of axis. The default is servo, which would be meant to map to a servo axis or an AKD drive in the system. You can also have a digitizing axis. This would be a half axis that would be connected to an external encoder, typically also connected to the X9 connector of an AKD drive, or a virtual servo or virtual axis that would not be tied to a real-world device, but could be used to a master for a gearing or camming function. You can also set up the user units here. This is done through setting both the user units option and the drive interface units parameter. Default user units is 360. This means for one rev of the motor, we have 360 user units, so we'd be working in degrees. If you have an integer-based user unit, you can just enter it directly. For instance, if we have some linear mechanics that for one rev of our motor, you get 5 inches of linear motion, you can just enter 5 directly in the user units parameter, and then the overall user units will be 5 inches per rev. If you have a non-integer or a decimal involved in your user units per rev, then you have to change both user units and drive interface units. The reason being is you can only enter integers for both of these parameters. I'm hitting a period on my keyboard and nothing is showing up in the user units parameter. That's because it will only accept integers. So, for instance, if I want 5.5 inches per rev, I can enter 55 under user units and add a 0 for drive interface units, and the ratio between these will end up having a 5.5 or 5.5 inches or centimeters per rev of the motor. The reason being is these two parameters act together as a ratio, and the overall or division of user units by drive interface units makes up our user units per rev. I can also keep adding zeros for drive interface units in order to get an extra decimal. So if it was 5.25 inches per rev, I can enter 525 and have 2 zeros added to the default drive interface units, and then it will result in a 5.25 units per rev. There is a limit to how many zeros, or thus how many decimals I can directly enter to get user units per revolution. If you do need to have more than 3 decimals, then you'd have to do a little bit of calculations. We have some examples in our online help menu. So under the Access Data Parameters section of our online help, there are some examples of how you would just have to do some simplification. So you'd end up having the exact same ratio. You have to do a little bit of math to simplify both the drive interface units, which act as the denominator, and the user units, which acts as the numerator, in the ratio that makes up the user units per rev. The update rate selection determines how often a new command position is calculated for this axis. I usually just keep it at the default or lowest fastest speed, and therefore that the new command position will be calculated each EtherCAT update rate. If you have a update rate selection that's faster than the EtherCAT update rate, the slower of the two will be used. For instance, if you have an update rate of 1 millisecond for your EtherCAT rate and 250 microseconds selected, then the axis will have a new command position calculated every millisecond, which is the slower of the two, or the EtherCAT update rate. You can also click a rollover position. By default, this is 0, meaning there is no rollover, and the axis position will just continue to accumulate to either a really high number, or if it goes in the counterclockwise direction, a negative number. If you select a rollover position, then you will never have a negative number, and the axis position will always stay between 0 and that number. For instance, if I go back to our default user units per row of 360 and enter a rollover position of 360, that means the axis position will always report it back as between 0 and 360. If the position goes above 360, it will roll over or go back to 0. Or if you go in the counterclockwise direction and go past 0, it'll roll over and start reporting 359, 358, and so on. Now that I've set up all the parameters for the newly created PLCopen axis, I can press OK. And there's one more step before we can start using this axis in a PLC program. I have to go to my dictionary, and I'll open up global variables, and you'll see in all of our template projects, we have an axis 1 and axis 2 already created, and it's of axis type axis ref. I can create a new variable called axis 3, or give it a more detailed name, and choose the type of axis ref, and then it'll be in my dictionary ready to use. I find it easier to just copy the existing variable, paste it, and then I have a variable of axis ref, and it's just very easy to change the name of it, call it axis 3. And if you go into a PLC program, in all of our template programs, you'll see in one of the initialization steps, we have a section where we assign an axis number to the name of the variable .axisref_num. So these variables, or axis ref, is really a structure, and one of the subsections of that structure is called axis_num. I'm going to copy and paste this, and I'm going to write a 3 into axis 3 period axis_num, or the axis number subsection of the axis 3 variable that I created. To make sure that this is the right number, in part of the axis data setup screen, there's this number, which you shouldn't change. This is automatically assigned. It just increments by 1 each time you add a new axis. But this is what number you want to input to the axis num subsection of the axis ref variable that we created in our dictionary for this axis. Now that I've created this new variable of type axis ref and assign the correct number to it, you can use it wherever axis input is called for PLCopen function block.